Bismillahirrahmanirrahim. Our today's topic is simulation. So, in this topic, we will discuss what is simulation and what are the advantages of simulation. So, before going into the details of this topic, I would like to start by an example. And let's say we are taking this example of coronary angiography. So, okay, so this was a procedure called coronary angiography, and I talk about the further details of this procedure. Okay, so now this is another plastic model of the human body, and in this model, these are the different arteries, and these are the heart chambers. And this physical model, this is a physical model. Explain you these things. This wire is inserted into the human body, and it is forwarded to the heart chambers. Okay, so now the point which I want to emphasize is that instead of the human body, we have used this plastic model or object for demonstrating this procedure. That this is the heart chambers, the heart chambers. Uh, this is the main artery on which this wire is passed through. So it is a copy of the human body, and this wire is the actual physical wire which is used in this angiography procedure. So this is again for demonstration, like for the instead of the actual procedure, we are demonstrating the process of angiography through this plastic model and using this original wire. Okay, now in next example, what we can do, we can consider all the instruments as virtual instruments. For example, this red color object is the artery, and this blue color object is the wire which we are using in this procedure. And we can use power computer programming to demonstrate this whole procedure. Okay, so now the point is that in the actual angiography procedure, we are using the actual physical human body, and we are using the actual wires. Then in the next example, I replace the human body by this model, and the wires are the original wires which are used in the procedure. And in this demonstration, we have replaced the physical model as well as the physical wires, and we have used a computer program to demonstrate this whole procedure. Okay, so now this is actually simulation. This procedure, this is also simulation. What is simulation? We are copying the original procedure through some models. This is a model, and we are performing the physical process through alternate ways. Okay, so here we are simulating, we are replacing the original procedure through this physical model and through this original wire. Okay, and in this example we are modeling the human body virtually through computer programs, through computer graphics. We represent all the physical objects through virtual objects, and we perform the procedure through programming. We are replacing the actual processes through virtual processes. Okay, so this is called simulation. Okay, and now we will go to the theoretical details. So what is model? We already know what is model: a representation of an object, a system, or an idea in some form other than that of the entity itself. We already know about this. And types of models, so we know about physical models and we know about mathematical models. Okay, so in the first example we use the physical models, and in the second example we use mathematical models. Okay, so simulation can be done either through physical models or through mathematical models. A simulation of a system is the operation of a model which is a representation of that system. Now this is important. In simulation we are interested in the operations. Okay, so models are the representations and simulation is the operation of the physical objects. Okay, the model is amenable to manipulation, which would be impossible, too expensive, or too impractical to perform on the system which it portrays. Now, for example, for demonstration purposes, and if we want to teach to medical students the process of angiography, so uh, ideally we need to have patients and we need to do experiments on the patients for teaching the students. But now this is in this situation, using humans for this experiment is not a good option. And if we can use some alternate ways like simulation, so we can easily teach the medical students without using these models. So up to great extents, we can teach them the process of, let's say, angiography through these simulation processes. Okay, so the operation of the model can be studied, and from this operation concerning the behavior of the actual system, that can be used. Okay, Now, what are the applications of simulation? So there are many applications. For example, designing and analyzing manufacturing systems. We can use simulation for these. Evaluating hardware and software requirements for a computer system, evaluating a new military weapon system or tactics, determining ordering policies for an inventory system, designing communication system and message protocols for them. So, in all these applications, we can use simulations before manufacturing the actual objects. Designing and operating transportation facilities such as freeways, airports, subways, airports, etc. Evaluating design for service organizations such as hospital, post offices, or fast food restaurants, and analyzing financial or economic systems. So in all these cases, uh, we can use simulation before manufacturing the objects. Now, steps in simulation and model building. Define an achievable goal, put together a complex mix of skills on the team, involve the end user, choose the appropriate simulation tool, model the appropriate level of details, start early to collect the necessary input data. Okay, now provide adequate and ongoing documentation that this is important. Develop a plan for adequate model verification. So what is model verification? Model verification means that we have to answer the question, like we have to get the right answers. Okay, do we get the right answers for our question? And we also have to do model validation. So what model validation means? Model validation means that do we ask the right questions? Okay, and develop a plan for statistical output analysis. Okay, now, choosing the appropriate simulation tools. So assuming simulation is the appropriate means three alternatives exist. First, build model in a general purpose language. So we can build this model using any general purpose language, and we can also use build model in a general simulation language. Simulation languages can be programming languages, and use a special purpose simulation packages. These are also possible. There are specific packages that are used for specific simulation purposes. Okay, now the real cost of through simulation we are actually reducing the cost. For example, in geographic case, I told you that for this we can use the human objects, but that is too expensive and that is too risky, and we can't sacrifice humans for such demonstrations. So we want to reduce the risk and cost using simulation, but simulation has its own cost. And many people think that the cost of the simulation is only the software package, but actually there are some additional components too in this cost. For example, purchase price of the software, programmer analyst time, and also timeliness of the result. So, okay, thank you.